Hey everyone, thanks for watching 3dmotive.com. This is Donald, and in this video we'll be covering how to create a junk pile using Reactor and a handful of the features in 3ds Max 2010. This tutorial is intended for beginner to intermediate levels, and it assumes that you know a little bit about object creation, 3ds Max navigation, and basic editable polygon functions. Now, by the end of this video, you should have a knowledge of how to use Reactor in conjunction with your created 3D props to create a convincing junk pile like what I have here. So the goal of this tutorial is to basically show you how to use the Reactor physics simulator to create a series of keyframed animations for each of these objects, and we will basically make them fall into a collection area, which is going to give it a very convincing result as if it were actually falling down into a giant pile. Now, if you could imagine trying to sit here and hand place each of these objects one by one, it could probably take you a considerable amount of time. But if you know how to use the Reactor simulator, you could quickly and easily apply a series of keyframes of animation onto these objects and have them all fall into very interesting pattern. And these methods will apply to just about anything you can think of, so feel free to get creative. So the first step in this process is going to actually have some 3D objects to work with. What I have here is an old tire, a rusty can, some cinder blocks, rebar pipes, and some bricks. Now the next thing that I'm going to want to do is I'm going to want to go ahead and make a whole bunch of instances or copies of my objects and line them up in such a way that if the objects were to fall straight down, all of these objects would fall down into a specified mesh that I have set up over here. Now the point of this object specifically is so that when we apply gravity and run the Reactor simulator, all of these objects are basically going to fall down into this circular shape that I have created to create a nice convincing junk pile in sort of a random round shape. Now you could easily use these techniques against a corner wall, for example, or if you wanted to just lay everything out completely flat. I tend to use the rounded circular shape to begin with because that allows a lot of the objects not to fall out of the world and everything to kind of tidily clump up right here in the center of this object. So what you're going to want to do is ensure that you have all of your objects lined up in such a way that if the objects were to fall straight directly down, they would fall down onto your specific mesh. The other thing that you're going to want to watch out for is to make sure that you look at it from a top view as well, to assume that, for example, this tire, if it was way out over here, it would probably fall outside of our catch mesh that we have set up. So make sure that you do that last little check before you start getting into the specifics. One other rule of thumb that's very important is that you make sure that none of your objects are interpenetrating. And what I mean by that is, for example, if I take this tire and I shove it directly into this tire or these bricks, what's going to happen is Reactor is going to give us some error messages whenever we try to run it. It's going to tell us, hey, you know, you've got some objects interpenetrating, and it may cause some errors whenever you decide to run it. So a quick and easy rule of thumb is going to go ahead and just make sure that you space all of your objects out just enough that nothing is touching each other, and that will guarantee that you have a very clean and successful simulation when you start using Reactor. Once all of your pieces are in place and ready to drop, we have two things that we need to create and add into our scene. The first one is a gravity object, and the second one is a rigid body collection. The gravity, it basically tells your scene just how heavy or light the gravitational pull is for all of these objects as they fall. And then the rigid body collection can basically be used to assign a specific set of parameters to each of your objects. And we'll talk about that in just a second. So the first thing, in order to create a gravity object, we want to go ahead and go over to Space Warps, and then make sure that we are in the Forces pull-down menu, and then go ahead and create a gravity object. So to create it, all you need to do is just left-click anywhere in your scene. It doesn't matter where this object is. It could be directly next to your objects. It's just a good idea to keep your scene nice and tidy because we will be adjusting some of these values a little bit later. So just hold down the left mouse button and then release, and that will create the object. So the actual icon size, again, is irrelevant. This is more just an aesthetic than anything. Now the actual strength of the gravity force is going to determine just how strong that gravitational field is. So by default, what I'll do is I'll set the strength on this to about 20. Now you're going to get different results whether you have a very low strength of gravity or a very high strength of gravity. So feel free to play around with some of the values when you run your simulation and find out which one is going to give you the best results for you. Now the next thing we need to do is we need to create a rigid body collection which will assign all of our objects to that collection. And the way that you do that is under the Create tab also. It's going to be under the Helpers, and it's going to be under the Reactor pull-down menu under RB Collection. So if we go ahead and click on that, just like the gravity object, all we need to do is just left click anywhere in the scene and it's going to create this RB Collection object. And then when you release the left mouse button, there's your object. So the next thing that we need to do is we need to go ahead and add all of these objects that we've created to this rigid body collection. So the way to do that is to go ahead and modify that object, and then down here we're going to go ahead and click on Add. And this is going to bring up a pop-up which is going to list all of the objects that you have listed in your scene. So if I click here, I can go ahead and select all and press select. And that, as you notice, all of those objects sort of popped up right over here under our RB collection properties. Now, we don't need the gravity object, so I can go ahead and delete that out. And now we're pretty much good to go. So with our rigid body collection object and our gravity object, the next thing we need to do is we need to go into the Reactor, and we need to go ahead and start playing around with some of the settings and go ahead and execute the command to run the simulation and see how this junk pile is going to look when it falls. So the way to access it is over here under the Utilities tab. You should see an option for Reactor. Now, if you don't see Reactor listed here, you can always click on More up here on the top left, and you may find it inside of here. And if you find it in here, you can go ahead and just double click on it to open it. So go ahead and click on Reactor, and that's going to go ahead and bring up the Reactor utilities. Now, by default, you may be set to Havoc 1. I'm going to go ahead and change mine to Havoc 3, which is a little bit faster. It's a little bit newer calculation. It's going to give you a much quicker preview when you decide to start testing this animation process. So there's a couple things you want to go ahead and set first before we get into running the actual simulation. And if you go ahead and expand the Properties tab, this is going to give you some different options based on mass, friction, and elasticity. Mass is basically going to tell you just how heavy or how light the objects are going to be. Now this works very similar to what we mentioned earlier with the gravity field. You can adjust this parameter as needed, and you're going to get some different results for it. The higher the number is, the heavier that the object is going to react. So the other thing to think about is down here at the very bottom, since we don't want this piece, this catch mesh to do anything, we're basically going to zero out all of these settings under mass, friction, and elasticity. And I'll talk about friction and elasticity in a second. But what I'm going to do is I'm going to go ahead and go into the front view, and I'm going to grab everything in the scene except for that last one. Go ahead and deselect that and make sure that I set all of these objects with a mass at a specific setting. Now, right now they're set to 20. I'm going to go ahead and turn this up just a bit to about 100. And part of the reason for that is when all of these objects fall, we want a real heavy collection down here at the bottom when everything clumps up. Now, friction is basically going to be just how smoothly all of the objects interact with each other. So down here on the bottom collection mesh, we're actually going to go ahead and set that back up to about 5. And that's just to kind of give everything a little bit of slide once everything falls down. The rest of your objects, you can leave everything to 0 if you want. And that's basically going to ensure that there's very little sliding going on with your objects when they drop down inside here. We don't want a bunch of stuff sliding all over the place and kind of jiggling around down there. So under friction, we're going to go ahead and set that to 5. Now, elasticity is going to basically be just how bouncy the objects are. So if I turn this up really, really high, everything's going to be very, very bouncy. So, maybe for the tires, or if you had like a bunch of rubber balls or something, you might set that elasticity really high. Whereas if you want to do a very hard pile of blocks and concrete and stuff, and you want everything not to bounce, we're going to go ahead and set that to 0 as well. Now, here under inactive, you can also set this if you want an object's property to be inactive. And what that means is that the object will basically remain completely still until something else hits that object. And so, for example, if you wanted to create a simulation of bricks, and you didn't want the bricks down here at the bottom to do anything until the bricks up top smashed into them, you'd want to go ahead and turn on that inactive. Now, the other thing that we want to do is down here for our base meshes, we want to go ahead and turn that as inactive as well. Since its mass is at 0, it's basically going to be completely removed from the gravity calculation. So the final step is to grab all of your objects, and you want to assign everything to a type of collision. Now, bounding box is going to be one of the most primitive of the types of collision that the object would get. So for example, if I zoom way in and you see the bounding box, which you can toggle on and off with the J key, that's the basic primitive collision that you can possibly get. Now, for stuff like the blocks and maybe even the rebar pipes, the bounding box may be just fine. However, for something like these tires, we're going to be wanting to use something like a concave mesh. And what that means is that other objects can fall inside of these objects. If we just set it to bounding box, anything would basically bounce and collide with the bounding box, which means nothing would fall inside of the hole that these tires have. So what I'm going to do is I would go through and I would just individually kind of select, what type of collision each of these objects would have, and then over here under the reactor, under simulation geometry, you want to go ahead and assign that. So for example, just grab all these tires. I want to make sure that those are set to concave mesh. And then for the blocks, we can probably get away with just using the bounding box. Now, one last thing to think about too, though, is that with a concave mesh, that is going to be more expensive. It's going to take a lot longer to calculate that. So use with caution. If you're doing a big pile of tires like this, and all of them are tires, the likelihood is you might not want a bunch of them to be able to fall into each other. Maybe you just want to do a stack. So play around with these settings until you find a collision setting that's fast for you and gives you the results that you want. So the final step with this is here inside of the reactor. If we go ahead and pull this up just a little bit, we're going to go ahead and run down to the utilities, and we're going to go ahead and click on Analyze World. And this is basically going to give us any of those error messages that we talked about. So what this is telling us here is it's telling us that there are some pieces that are interpenetrating. And so your next step would be to basically address any of the issues that it says that you have, whether objects are interpenetrating, if something doesn't have a collision type. Lots of these things are types of errors that you would get here inside of this message. So this is telling us that box 9, 10, and 11 are interpenetrating. So if we go up to our list, we can quickly find those objects if we just sort by name, and then grab those objects and find out what's going on with them. So go ahead and hit OK. And what's happening here is it's basically telling us that the collision is colliding just inside of the catch mesh, that we want to go ahead and move these out of the way and just make sure that they're kind of off to the side here. And we also need to make sure that our bottom mesh is set to a type of collision as well. And we're going to go ahead and change this to a concave mesh because we do want all of the objects to fall inside of them. So to preview the animation with our physics simulation, all we need to do is here under the Preview and Animations tab is we need to go ahead and click on the Preview in Window. And this is going to bring up a brand new window, which is basically giving you a example of what your reactor simulation is going to look like. And if you go ahead and just press the P button, as it says down here in the bottom, that's going to go ahead and run the simulation based on all of the settings that we've set. So what you're seeing is all of the objects are falling down here into our collection mesh, and this will be a good time for you to kind of take a look at it and see if there's anything weird going on. Maybe your collection mesh is too small, maybe some of your collision isn't working correctly, but this is basically giving you a preview of the simulation before you actually commit the simulation to take place inside of your scene. So to navigate around, all you need to do is just go ahead and scroll your mouse back and forth, or hold down the left mouse button to kind of drag it. Now, once you've run the simulation, you can always reset it by clicking Simulation Reset, and then just kind of frame it, and then once again press the P key to go ahead and play it. Now, as this is playing, I'm looking at what is happening down here also under the time counter, because when we go to actually commit the animation over here inside of Reactor, we want to go ahead and make sure that we give ourselves enough keyframes based on the amount of time that it takes for the simulation to run. So if I go ahead and close this, what we're looking at over here is we're looking at the end frame, and this is basically the number of frames that simulation took place. So once again, if I go ahead and preview it and I play it, what we're looking at is basically how many seconds the animation takes for everything to collect and for everything to be correct down here. Now, I'm looking at probably about 15 seconds or so of time, and in the basics of animation, that's approximately, about 32 frames per second. And so if we take 32 frames per second and we multiply that by 15 seconds, we get about 480 frames of animation that we'd be looking at. So just to play it safe, I'll set that to about 500 and go ahead and press enter, and that's going to go ahead and set this up so that we have exactly 500 frames of animation that is going to be created for our final animation. Because basically what we're doing with the preview is it's just sort of giving us a hint of what the final calculation is going to be, but when we click on create animation, that's basically going to actually commit the scene to making some changes. So this is probably a good a time as any to go ahead and save your scene, because if you go ahead and click on that create animation, it's going to give you an error that says, or not an error, but it's going to give you a pop-up that's kind of a warning that says, are you sure you want to create an animation? This action cannot be undone. So make sure that you save a copy of this file in the event that you decide, hey, this didn't quite work out, or maybe I want to try something else with it. Before you actually commit to it. So we're going to go and commit to it by clicking on Create Animation and then go and press OK. And then down here at the bottom, you're basically going to get a preview bar. And what that's doing is that's essentially, calculating very similar to how we did in the preview, only this is doing it for real, basically. So once that's done, you can go ahead and press on Close. And then now, by selecting any of your objects, you'll notice that it's created all of these keyframes of animation. And as you scrub the time bar back and forth here, you'll notice that all of your objects are starting to kind of fall down here in the scene. Now, don't worry if right off the bat you'll notice that you're only set to about 100 by default. All of your 500 frames should be there. In order to change that, all you need to do is down here in the right-hand corner, click this little button down here, which is the time configuration, and that's going to go ahead and adjust the frame count for your slider here. So for frame count, I'm going to go and set this to 500 and press enter, or in length, and then press OK. And so now if we scrub the time bar, you'll see that all of the objects are basically falling very, very similar to how we had originally in the preview. So if I frame this up just a little bit, you can kind of see all these objects are falling, and then they're kind of settling in a rest state. So once we have all of our objects clumped together down here, there's just a couple little things that we need to do to go ahead and clean this up. We can go and exit out of Reactor, and I'm going to go ahead and pull the command panel over to the side just a little bit. And now we don't need this rigid body or this gravity object anymore, so I can go ahead and delete that. And you can also select on the catch mesh down here at the bottom and delete that as well. Because basically what we're looking for is we're looking for this pile of objects, which basically clumped just like what we were looking for in our Reactor simulation. So I'm going to go ahead and turn on the hardware shading and go ahead and turn on ambient occlusion just so you can get a nice visual look of what our junk pile looks like. Now, you will notice that sometimes you're going to have some problems with some of these meshes, like this over here, for example. These rebar pipes are probably not 100% accurate, because we know that when we ran our simulation, they basically fell and were clumping up onto the side of our catch mesh. And sometimes you may have to do just a little bit of cleanup, but nothing says you can't just, kind of grab those and, pull them in somewhere else, or manually go in and make a few minor adjustments to those meshes as needed. I'm just going to go ahead and kind of pull them up and down just a little bit. It won't be quite as noticeable if we just go ahead and kind of bury them underneath some of these other pieces. That should be fine. So once I'm happy with that, I can just kind of, basically all I'll do now is just a last little check just to make sure that, everything sort of makes a little bit of sense. Now, this tire may be a little bit off here, but I think for now we can go ahead and just leave that guy there. You want to make sure that nothing's leaning towards something without a reason for it, like what we mentioned earlier with these rebar pipes. So the last step that I will do before I get this ready, whether it's for a game asset or an environment scene, is I want to go ahead and make sure that I get rid of all of the keyframes of animation, and I basically merge everything together as one single object and then kind of clean stuff up just a bit. So I'm going to start by drag selecting all of the objects in my scene. And then down here on the timeline, if you hold down your left mouse button, you can go and just drag select over all of these keyframes of animation and then press the delete key. And so now what you've done is you've deleted out all of the animation information of this object, and you've basically committed to saying, hey, this is my junk pile, no more animating, and there's no going back. Very similar to, the reason why we want to save our multiple copies of our files, just in case we decide that we do want to make some changes. So what I'm going to do next is I'm just going to go ahead and grab any one of the objects. It doesn't really matter which one. And under the Edit or Modify tab, I'm going to go ahead and click on the Attach dialog box here under the Attach List, and then go ahead and click on Select All. And that's basically going to attach all of the objects together as one single object. Now, you'll notice that the bounding box is a bit off, and that's because of we need to go ahead and reset our transform. And I'll do that over here under the Utilities tab, under Reset X-Form, and go and hit Reset Selected. So now the rotations and scale and everything should be accurate. So now that it's down to a single object, the last little bit of cleanup that I would probably do would be to go in and just clean out any of the bottom faces underneath the bottom of the object. So, for example, this is a very unique object. I could never turn this thing on its side, and it wouldn't make any sense if this was rotated. So obviously, there's really not a lot of reason why the player or the person would ever see some of the bottom faces of this object. So what I would probably do is go in as just one last little bit of check and cleanup, is to go into the bottom of the object itself and grab any of those faces that I know that the player is never going to actually see. By looking at the object from up here, I can tell that I can't see any of those selected faces that I have right now, but looking at it from the bottom where the player is never going to be able to get to, those are probably safe to go ahead and delete. Now, one other thing that you can also do is take advantage of using the bi-angle selection and the ignore backface selection. This can help speed up large selections of polygons. You want to be a little bit careful when using the bi-angle selection. Sometimes it can be a little tricky, and it may accidentally grab some stuff behind your object unexpectedly. So use with caution, but it can definitely be a great help for selecting a large group of polygons when you want to go through and do a last little bit of cleanup on your object. Now that we're all done, I've gone ahead and brought our object here into UDK. This is basically what a typical asset could look like using some of the techniques we've covered in this video. I hope you've enjoyed the tutorial, and don't forget to check out our other content, including a free video on how to import meshes just like this directly into UDK. Thanks again for watching 3dmotive.com.